So here we're going to be talking about the factor theorem. So this is kind of an extension of the remainder theorem that we just looked at. So we say the definition is if f of x equals 0, then h minus x is a factor of x, or the other way around. If h minus x is a factor of f of x, then h of x equals 0. So basically what it's saying is if the remainder after a synthetic division is 0, then the divisor and the quotient have to be factors of that polynomial. This sounds confusing, but it's not confusing when you kind of just see an example of it. So just watch this example here. So it asks, show that x plus 5 is a factor of 2x cubed plus 7x squared minus 9x plus 30. Okay, so we set up our divisor as we know. So x plus 5, that's going to be minus 5. Okay, so our coefficients are 2, 7, minus 9, and 30. Okay, so we know 0 plus 2 is 2 times negative 5 is going to be negative 10, and plus 7 is going to be negative 3. Negative 3 times negative 5 is plus 15, and then negative 9 plus 15 is 6. 6 times negative 5 is negative 30. Add these two together here, and you get 0, okay? So here the remainder in there is 0, okay? So what does that mean? Okay, so this is like we were saying here, if the remainder is 0 after the division, then the divisor and the quotient have to be factors of the polynomial. So that's one way of saying, show that x plus 5 is a factor. Well, the remainder is 0, therefore x plus 5 must factorize perfectly into this polynomial here. So you'd say x plus 5 is a factor. Okay. Yeah. So again, I'll go on and do another example to try and make this a bit more clear. Okay, so in this question we're asked, show that x plus 2 is a factor of this polynomial here, okay? Then fully factorize it. Okay, so set up our L, so x plus 2, so this is going to be negative 2, our coefficients are 1, 7, negative 26, and negative 72. So this is going to be 1, 0, this is going to be 1, this is going to be negative 2, this is going to be 5. 5 times negative 2 is negative 10. Negative 10 is going to be negative 36. Negative 36 minus 2 is positive 72. So the remainder here is 0. Okay, so remainder 0. There, 0. Therefore, x plus 2 is a factor. You need to put a little statement like this to get the marks in the exams. Okay, but we're not done yet. It says fully factorized. So now what we're left with? Well, we know that x plus 2 is a factor. And what we do is we write out our quotient here. But remember, it goes down by one order. So this is going to become x squared plus 5x minus 36. Okay, so this is just a quadratic that's going to need to be factorized, and we've got what we're trying to find out is two numbers that add up, multiply together to make minus 36, and add up to make 5. So 36. What are the factors of 36? So they are 6 and 6, well 36 and 1. But they seem a bit far apart. 36 and 6, 6 and 6, and 4 and 9. Okay, do any of these have a difference of 5? When you take one away, they have a difference of 5. Yeah, so 4 and 9 has a difference of 5. Okay, now when you think we want a negative 36 and positive 5, so this is going to be negative 4 plus 9 is positive 5. Okay, so your two numbers are going to be 4 and 9. So x plus 2, and then it's going to be x minus 4 and x plus 9. So those that's your expression fully factorized. Okay, well, what does this mean visually? Okay, so that's all good and well, but what does this mean visually? So I've graphed the graph of this polynomial. I'm going to have a look at the result. Okay, so here's it here, the same one that's in the question. And we remember that our factors were x plus 2, x minus 4, and x plus 9. Okay, so what's happened here is we can see that, what's this point here where it crosses 0? This is negative 9, right? So that's the same as when you had x plus 9. When you did your root, that's going to be negative 9. So that's what it means there, okay? And then you've got your next root here, which is minus 2. So that was the x plus 2 factor. Then you've got your last root here, which was x minus 4. And that's your factor here. So basically what it means is saying, when you have a factor something, that means when is it going to hit 0. So if you substitute in negative 9 for x, you're going to get 0. When you substitute in negative 2 for x, you're going to get 0. When you substitute plus 4 for x, you're going to get 0. And this is what this graph visually represents. And that's what you're trying to figure out when you're solving and factorizing these. So I hope that helps you kind of give you a bit more of a visual idea of what these factors are and what they mean and why you kind of set them equal to 0.